Self-encryption is a process used to ensure that all your data stored on the safe network is unrecognisable as data and resistant to decryption. So here's how it works. Let's imagine you have a Word file that you would like to store on the network. The safe network takes the file and divides it into a minimum of 3 chunks. We'll call these chunks C1, C2 and C3. When this chunking process is completed, the system creates a data map, which is predominantly 2 lists, pre-encryption and post-encryption. The system takes a hash of each chunk. A hash is basically a digital fingerprint. No 2 fingerprints have the same pattern. Likewise, every hash is unique. The hash of C1, C2 and C3 are written into the pre-encryption list in the data map, and then each chunk goes through an encryption process. It's important to note that the safe network uses encryption at this stage only to turn each chunk into random and non-repeating data. The way the safe network handles this obfuscation is by encrypting C1 using the hash of C2, C2 is encrypted using the hash of C3, and C3 is encrypted using the hash of C1. The algorithm used for this encryption is AES 256. The chunks then go through an XOR process, where each chunk is obfuscated by XORing it against the hash of other chunks. So C1 encrypted is XORed with the hash of C2 and the hash of C3. C2 encrypted is XORed with the hash of C3 and the hash of C1. And C3 encrypted is XORed with the hash of C1 and C2. A hash is then taken of the obfuscated chunks and written into the post-encryption list in the data map. The data map is now a complete key to the original data, your Word file. At the same time, the final chunks which have undergone encryption and obfuscation are randomly distributed across the safe network and stored on vaults on computers. The network maintains a minimum number of live copies of each chunk at any given time. So if one chunk were to go offline, it would be noticed immediately by its replicates and a replacement produced. But I'll save that explanation for another time. So when you want to retrieve your Word file, which is now meaningless chunks of data spread across a decentralised network, you log in with your credentials and the data map retrieves the chunks from the network and reconstitutes the original Word file. This whole process takes place seamlessly in the background with absolutely no disruption to the user. Also happening simultaneously is the deduplication of data on the network, with the potential to save significant percentages of disk space worldwide. This unique combination of data encryption, obfuscation and decentralised storage provides users with a secure and anonymous solution.